So systems of linear equations is when we have two or more linear equations right here. So like this, here is my x and my y axis, and here are my two lines. Both of those lines have linear equations. When those two cross, that system of linear equations is the solution of the system. Meaning this point right here has a point on that x and y axis. That coordinate plane does say right here, this is the solution for that system of linear equations. Now I know there's a lot of words thrown out at you, but in 1 second that'll make a little more sense. So we're going to learn how to solve this by graphing them. So let's say I've got two equations for lines, two linear equations. So I've got y equals negative x plus 1, and then I'm put a different color. Y equals 2x plus 4. All right. Let's go back to graphing, which we did learn, which is that when I'm graphing my first equation right here on the top one, which is in yellow, y equals negative x plus 1. My starting point, if I am just doing this without picking points, but by graphing, I know that this 1 right here is my y-intercept. So I'm going to start right here at the point where x is 0, y is 1. Now, negative x means that I go, it's kind of like negative 1x, and negative 1x can be written as negative 1 over 1. So I'd go down 1 space over to the right 1 space, which would put me right there. Down 1 over 1, again, 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 and look at that. If I were to go backwards, I'd go up 1 into the back 1, and so on and so forth. Now, forgive me because this line is not going to be perfect, but I think you'll get the idea. Pretend that my handwriting and my drawing skills were just amazing. Okay, now I've got that line right there. Now for the second one, it says my starting point is 4. So I go where the x is 0, y is 4. So 1, 2, 3, 4 spaces. Okay, it says 2x, meaning 2 over 1, which is like up 2 over 1. So if I start at that point, if I start right here and I move up 2 over 1, that puts me right here. Since I ran out of space, I'm going to go down 2 into the back 1, down 2 into the back 1, and all that again. And again, I think if you could bear with my amazing drawing. Okay, now we know that really what this is supposed to be is this point right here. Again, my handwriting, my drawing, they're not perfect, bear with me. But they do cross that point right here. That point is at what on this x and y are our coordinate plane. So we have our x and we have our y, so we'd say it's right here. Well, that's negative 1 and 2. So I would say that this is at the point negative 1 and 2. So you're saying, well, what does negative 1 and 2 mean? That's actually our solution for both of those lines. And let's test that to make sure. So like I said, our solution was negative 1 and 2. Our first line was y equals negative x plus 1. Our second line was y equals 2x plus 4. Let's substitute in the values and see if that works. So this is a y value is our 2, and negative 1 is our x value. So we'll say 2 equals negative, and now I know there's a negative in front of this 1 right here. But there's also a negative here. You can't just say, well, it's negative and that's fine. There is that negative sign needs to come down, and our x value is actually negative 1. Plug that in. Okay, negative 1 is actually positive 1. So we have 1 plus 1, which equals 2. Does that mean that 2 equals 2? Yeah, awesome. We got it right. Let's try it again. Take this value for our y, plug it in down here and say 2 equals, and then we're going to take negative 1, plug it in over there. We're going to say 2 times negative 1 plus 4. It's 4. Okay, 2 times negative 1 is negative 2 plus 4. Okay, 2 equals, well, negative 2 plus 4 is not negative 6. It's actually 2. 2 equals 2. So what we got there was we have a solution set, which was this right here, negative 1 and 2. Those numbers, that x and that y, or that input and that output, are true for both of these equations, that is a system of linear equations, and we just solved it by graphing. So let's try again, and I'm going to give you y equals x minus 6. And let's do another one where we have y equals negative 2x. All right. So for the yellow one, y equals x minus 6. We know that we start at the point where x is 0 and y is negative 6. Okay. If x is positive, just x, that means up 1 over 1, because that's like saying 1x, and that's like 1 over 1. So we go up 1 over 1, up 1 over 1, up 1 over 1, and all that again and again, and we will get this amazing, amazing line. Now we do the next line, and we say y equals negative 2x, and you say, oh, whoa, 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 whoa. There's no plus or minus anything there after it. So that means that's where the point 0, because we don't add or subtract anything. It just starts at 0. So now we have negative 2x. That's like negative 2 over 1, which means down 2 and to the right 1. So we go down 2 spaces to the right, down 2 spaces and to the right, and we hit that, down 2 spaces and to the right. Okay. Again, my truly amazing line is right there. The point where they intersect is there. That point, if I were to say what are the coordinates of it, you'd say, well, let's see, I moved to the right 2, so x is 2, and I went down negative 4. So there's my ordered pair, or my solution to the system of linear equations, and we'll test it again just to make sure. So like I said, I had the solution was 2 and negative 4. Let's plug that in. We had y equals x minus 6, and we also had y equals negative 2x. Okay, if this is our x value, put it in. If this is our y value, put it in. We'll say that negative 4 equals 2 minus 6. I hope you can tell me that 2 minus 6 is not like 18 or 24, but actually negative 4, which is true. All right, let's try it one more time. Plug in my x value and plug in my y value. I got negative 4 equals negative 2 times 2. Negative 2 times 2 is negative 4. So look at that. It works. One final note here is that if we have a set of, and let's do this. If we have a set of parallel lines, and now imagine those are perfectly parallel, they will never actually intersect. So if they do not intersect, they are parallel, meaning there is no solution because you cannot find a single point that will ever be on both of these lines. So there is no solution for that. Also, what if you had two lines that were the same, as in like we had this line and then we put this one right on top of it? That means they are the same line, as in there are infinite number of solutions.